Another example of timing is typically for natural resources. Suppose you're considering whether or not to buy a shale oil field. Okay. Do you guys know what shale oil is? You basically get oil from the rocks. Okay. It's incredibly expensive, depending upon where it is. It costs anywhere from $45 to $60 a barrel to extract that oil, including the development of the whole field. Let's see where the crude oil prices are right now. Well, they're trading at $61 just a few months ago. They were trading as high as $80 a barrel. And I'm considering whether or not to buy a certain shale oil field. Obviously, there are other things to consider. I got to finance that thing, yada, yada, yada. So as of now, purchase of this shale oil field may have negative NPV. But there's no such thing as if I buy the field, let's say it has proven reserves of 10 million barrels. It doesn't mean I have to take those out. So if when oil prices are low, I'm just going to sit there. If I think that after volatility is resolved, oil prices are going to go back up to $80. The reason they went down to $60, all this action created an expectation in the market that there's going to be a recession at first or slowdown of the growth. And the growth is expected to slow down or go negative. There's going to be less demand for oil. Again, economics 007, not 001, but simple as that. But that doesn't mean this is not going to go away. So I have the option not to extract it, and I'll extract it when it goes back above $70 and make money. That means timing options have value. There's another kind of option that they're called strategic options. These are options management have to go into related businesses when a project goes alive. Example, we know NVIDIA is making a lot of money from this AI chip business. They're technically chips for massively parallel computing, which is useful in machine learning applications, where you have millions of variables in models. And normally in a single chip, it takes months to handle them. But with AI, it takes only seconds. But these are expensive. At the time they're considering these, they had no idea there was going to be a demand like this. Or I think the demand for AI chips surprised even the NVIDIA people. Let me put it that way. But if that project goes live, suddenly they have options to do something. For example, by developing this technology even better, they could actually make it small enough to be used on PCs. Suddenly, NVIDIA has the option, assuming they could develop its technology better, to be in the PC business. So even if their projections show them that just these GPUs alone, that's what they call them, may have negative NPV, that doesn't mean that there aren't other options to go into related businesses. If you don't develop these AI chips or AI units, you cannot go into PC business. But if you develop it and if it becomes successful, even if not financially so, it could allow you to go into PC business. So those are strategic options. Again, we're not. How to handle strategic options depends on a lot of things. Typically, we handle those in graduate classes, not in MBA classes. If you had a Master of Science in Finance, I would actually cover something like that in the corporate finance class. Now, in addition to those, we could also analyze these estimates from two perspectives. One is called sensitivity analysis. These help identify inputs that has significant effect on the MPV. Sensitivity analysis kind of does a thought experiment. It's kind of a what if experiment. In this case, our estimate of sales was 2.77 million, right? Suppose we could assume that we could keep all the other inputs the same. The Latin name for that is ceteris paribus. I mean, in real life, nothing is paribus, but ceteris paribus means keeping everything else the same. I vary the sales amount by $100,000. What sort of effect does that have on NPV? And we could figure out which variable creates most sensitivity on NPV. Once I identify that, I could basically go ahead and, okay, let's think about that, maybe do a little bit more analysis. If my marketing survey used only 100 respondents, how about we spend a little bit more money and use a better survey with 10,000 people on it, or purchase some big data and do some machine learning model. You could do a lot of machine learning over the cloud, better models, but it's going to cost you a little bit more, and get estimates that have less uncertainty about them. It kind of helps you identify that. The second one is called, come on, man, scenario analysis. Where you create reasonable best and worst case scenario, and evaluate the projects under those scenarios. The reason you do this, the sensitivity analysis is useful to identify the inputs that derives or that affects the MPV estimates the most. It kind of ignores the fact that the remaining inputs are not independent of the input that you're varying around. If I'm varying the sales, more often than not, my costs are going to be varying. For example, if sales go from 2.77 million to 3.77 million, that means more than likely I'm going to need more net working capital to support those sales. Inventory, accounts receivable, and stuff like that. Or that means I'm going to have to produce more. Well, when I produce more units, production costs are not fixed. It's a combination of fixed costs and variable costs. So if I'm producing 1,000 more units, it's going to cost me more. So sales and costs are going to kind of sales and variable costs are going to move together. Or in order to support higher number of sales, I may need more machinery. So those kind of things are not independent of each other either. So scenario analysis basically admits that inputs are not independent. As we say in statistics, they're correlated. And we kind of do a best case and worst case scenario. Example, suppose this is a very simplistic example, but it kind of makes the point. Suppose your inputs are subject to forecasting errors plus or minus 10% of the current estimates.